we are going to conduct load test on DC Shunt Generator. As you can see, again we are using a motor coupled with a generator. So on the left side we have motors and on the right side we have the generator. So basically there are two parts in either generator or motor. We have the armature and field. The field winding is connected via 140 ohms rheostat, and the armature is connected via 50 ohms rheostat. Okay. So when the motor rotates, the motor being connected mechanically to the generator, being coupled mechanically to the generator, the armature of the generator rotates, and the current that is flowing to the field winding is controlled by this 50 ohms rheostat. So we have kept this 750 ohms rheostat. 750 ohms rheostat is kept in cut in position initially. So we are blocking all the current that is flowing through the field winding. Okay. So if you see on the right side, we have connected a 750 ohms rheostat and an ammeter that is 0 to 2 amps, which is connected in series with the field F1, F2. So this will measure field current. Okay, and we also have an ammeter which is connected in series with the armature, and the range of that meter is 0 to 20 amps. So this will measure the load current, the current that is flowing through the load. And this voltmeter is actually connected across A1 and A2. So this will measure the voltage that is generated in the generator. So as you can see, there is a DP ST switch, the right side of which is actually connected to the load. So we have the lamp loads that are there controlled by switch, and that is actually connected to the DP ST. Okay. Okay, let's start the experiment. So initially 750 ohms rheostat is in cut-in position, 50 ohms rheostat is in cut-in position, and 140 ohms rheostat is in cut-out position. Now the supply switch is closed. So Janardhan closes the supply switch and he checks for the speed. Now Arvind is going to bring the motor to rated speed by wearing 50 ohms rheostat completely. Check the speed.
1120, 1283,
Okay.
1358.
After completely wearing 50 ohms rheostat,
1370,
140 ohms rheostat needs to be very, very, very,
1222,
very.
1371, 1372, 1387, 1402, 1421, 1432, 1440, 1446, 1461, 1470, 1481, 1500, 524.
Check the speed.
1519,
Reduce it.
517, 512, 1507, 501.
Okay. Enough. So we have brought the motor to rated speed now. You can see the voltage is not yet built up. It's because we have blocked all the current that is flowing through the field winding. So the next step would be to allow current to flow through the field winding. So cut out 750 ohms rheostat slowly and see that the voltage builds to around 220 ohms. So very. Come on, very. Little more. 200. Okay, stop. Okay, so now the voltage is built up 220 volts. So you can see the field current also increasing a little bit, but the current now the current load current is going to be 0. Okay. Now close the switch, DPST switch, and you can take down one set of reading. So you can take down the field current, the armature voltage, and the current is actually 0. Okay, so switch on. Now for the second reading, you can switch on the lamps. One more. Okay, you can see the lamp is glowing. So the lamp glows because of the voltage that is generated by this generator. You can see as the load is increased in steps, the current also increases. So note down current and currents and voltages,
Speed.
as well as the speed. So for each and every set of readings, make sure that the speed is 1500 rpm. If the speed goes down, then you have to vary these two rheostats to make the speed as 1500 rpm. Okay. So increase the load in steps. This is for the next trial. So you can note down the currents and the voltages. Okay. So after finishing all your trials, you have to follow the reverse procedure. So switch off the load one by one. And remove the DPST switch. Bring the voltage that is generated back to 0. Cut out 140 ohms rheostat and cut in 50 ohms rheostat. And remove the supply. So after conducting this experiment, you need to find out the resistance of the generator, so the armature winding. Okay, and use it for your calculations. Okay, thank you.